This is your review for Unit 3. And the first thing we're going to talk about is converting between degree measure and radian measure. For this, remember, we use those unit fractions. If you're going to remember something or if you're going to put it on your cheat sheet, one easy thing to remember is that 360 degrees is the same as 2 pi radians, because both of these signify going around a full circle. What we usually do with this is divide each of these by 2 so that we have 180 degrees is equal to pi radians, and then we use that to make our unit fractions. For our unit fractions, we have either 180 degrees over pi radians or pi radians over 180 degrees. First, let's take this and convert this degree measure to radians. To use one of these unit fractions, we just need to figure out which one to use. Since we have degrees and we want to cancel that out and get radians, that means we want to use the unit fraction that has degrees on the bottom, which would be this one. We can take our 465 degrees times pi radians over 180 degrees. That way the degrees cancel. Then what we have is 465 over 180 times pi. The unit that's left here is radians, so we know that it will be in radians. And you can use your calculator to reduce this fraction. We can just put in 465 divided by 180. If we want a fraction, use the math button, the frac function, and press enter. So if we're trying to get an exact answer for this, this would be 31 pi over 12 radians. For the next one, we're trying to go from radians to degrees. This time we're starting with radians on the top, so we want to use the unit fraction that has radians on the bottom so that it will cancel. That would be this one. We have this value in radians times 180 degrees over pi radians. The radians will cancel and the unit we'll end up with is degrees. We can cancel the pi, and then we'll have -7 times 180 on the top, 10 on the bottom, and that turns out to be a -126 degrees. Here's another one where we're starting with radian measure. This time it's as a decimal instead of having pi with it. We're still going to use the same unit fraction. We have 2.4 radians times 180 degrees over pi radians. The radians cancel, but this time we don't have a pi here to cancel. What we end up with here is 2.4 times 180 degrees divided by pi. In this one, we're supposed to round to the nearest tenth of a degree. Dividing it on my calculator gives me 137.5 degrees if I'm rounding it to the nearest tenth of a degree. Be careful with these types of problems, whether they ask for an exact answer or for an approximation. If they're asking for an approximation, they'll tell you how many places to round it to. Now let's look at some examples that involve radian measure and the unit circle. One thing that will be helpful for you to remember is that a full revolution or a full rotation is the same as 360 degrees. It's also the same as 2 pi radians. So this one revolution would be 2 pi radians. If we're talking about something making 3 full revolutions, then the amount in radians is going to be 3 times 2 pi radians. That's going to give us 6 pi radians. This is the angle that it has rotated through in those 3 full revolutions. And a lot of the application problems talk about something having a certain number of revolutions or rotations. This is something that you really need to remember. Next, we're looking at the unit circle to find exact values of these two trig functions for angles in radian measure. But first, let's do the tangent of 7 pi over 6. To do this, you can memorize the values for tangent. I just use sine and cosine since tangent is sine over cosine. So what I would do with this is remember that the tangent of 7 pi over 6 is going to be the same as the sine of 7 pi over 6 divided by the cosine of 7 pi over 6. I need to find these two values. So first let's locate where this would be on the unit circle. If I'm looking at 7 pi over 6, this is in the pi over 6 family because of the denominator here. And right away that tells me that my reference angle is pi over 6. So here's pi over 6, and 7 pi over 6 is actually pi over 6 plus pi, because it would be pi over 6 plus 6 pi over 6, which means it's exactly halfway across the circle from pi over 6. So here's 7 pi over 6. It's in the third quadrant. That means when we go to do our sine and cosine of 7 pi over 6, both of those are going to be negative values. Now if we go back and look at our values for sine and cosine for pi over 6, if we're actually thinking in terms of the unit circle, we could figure out the points on the circle for that angle. Pi over 6 is one of our special angles. It's the same as 30 degrees. So the x-coordinate of this point, if we're on the unit circle, would be the cosine of pi over 6, and that is equal to the square root of 3 over 2. The sine of pi over 6 would be the y-coordinate of this point, and that's equal to 1/2. So if we're talking about this point on the unit circle, it would be the square root of 3 over 2, 1/2. That means that for our third quadrant angle, it's got the same values, only they're both going to be negative because we're in the third quadrant. So we would have negative square root of 3 over 2, negative 1/2 for our point coordinates. And that means that we're going to put those in for the sine and cosine here and divide them. So this tangent of 7 pi over 6 would equal negative 1/2 divided by the negative square root of 3 over 2, which gives us a positive 1 over the square root of 3, or if you rationalize the denominator, that would be the square root of 3 over 3. This problem also asked for the cosecant of pi over 4, so that's a completely different problem. But we're thinking of the same idea. First of all, cosecant is the same as 1 over sine. That means the cosecant of pi over 4 is the same as 1 over the sine of pi over 4. Pi over 4 is a first quadrant angle already. Pi over 4 is the same as 45 degrees. For pi over 4, both the sine and cosine are the square root of 2 over 2. If I'm looking at my unit circle, that's the x and y coordinates of this point. The only one we need for this is the sine, so that's the square root of 2 over 2, and that means we can flip it over to get the cosecant. That would give us 2 over the square root of 2, or if we rationalize the denominator, that just gives us the square root of 2.